First of all, we would like to know the people listening, what would describe your current role? If you don't want to answer, it's not mandatory. Many different results, I see. Okay, good. So mostly researchers. Also, important question before we start with the topic. What's your understanding and how familiar are you with asset manage? Okay. So many people exploring this concept, I see. We can start with a little bit of background in this case. So basically, what we are tackling the issue here is we have a worldwide challenge, a situation that started around 70 to 75 years ago with massive expansion projects, especially in developed countries. And now this infrastructure has been aging for decades. And Ebenezer, sorry, could you mute yourself, please? Oh, thank you. So this project of expansion that started around 70 to 75 years ago, it was not continued as it should have been. And as a result, now we have vast extensions of aging infrastructure with obsolete materials, with exhausted life cycles of the assets, increase of breakages, and also we have problems with data because we have data that is too old to know if these pipes have a history of leaks or breaks. And we have pipes that are too modern and too new, and we still don't have enough information to know if these pipes have deteriorated or to estimate their life cycle. So overall, we have a very complex situation in our hands, and from Vigeo, we have been a small company for over 20 years now, started by two friends at the beginning of the century. They started with traditional engineering projects and over time started shifting to open source and GIS. And now it is a company. Oh, of course. One second. So the company Vigeo, mid 2010s, late 2010s, started pushing GIS Water, a new software at the time dedicated to water utilities and to hydraulic modeling. And over time, it started growing. The team also started growing. The partner directors started looking for young talent. And most importantly, we have a common goal, which is to suit our clients' needs. So asset manage in this case, it was a logical response from us, seeing the needs of our clients and the needs of water utilities. And therefore, we thought that we need to democratize the access to information and we need to optimize the decision making based on the data that we have, that sometimes it's high quality, sometimes it's low quality. We cannot predict the data that we will gather. So with this context comes asset manage and everything that we will be talking about today. Our speakers will be Xavier Turret Raquena and Namrata Karki. Xavier Turret partner director at Vigeo, technical manager of the Gis Water Association. He has extensive experience in asset management systems, in hydraulic modeling, and data-driven decision-making for water utilities. And he's also the leader of the development of Asset Manage. And Namrata, she's a bright young engineer from Kathmandu, Nepal. She's a specialist in hydraulics and mathematical models. And she's also the current supervisor of the Asset Manage development. So without further ado, Xavier, the floor is yours.
Thank you so much, David. It is a pleasure to be here explaining what we are doing and what we are doing. No, I think David did a very good explication. No, what we are doing. Maybe we need to finish the Mentimeter, David, or how it works. This. David?
Sorry, I could not unmute myself, so we
Sorry,
can.
no, we would maybe we have some question more of Mentimeter, no?
Well, I think this is the
Last one?
last one, and then we have an open-ended question, but we can skip that one because we don't have that much time.
Vale, okay. Open source, open-ending questions. Okay, the presenters. Okay, myself and Namrata, as David mentioned before. And okay, let me make you a little introduction. No, why pipe replacement decisions matter. No, the thing is that we build lots of pipe networks, pipe systems, in special no after the Second World War, the entire world developed new urban areas, and everybody, at least in the development countries, no, everybody did a lot. And right now, that pipes they are aging and should be replaced. But it is not possible to replace everything because there is no capital, there is no money for replace everything. No, it's fundamental to try to prioritize. And this is the tool that today we will present. No, how prioritize your replacement. No, because it is not only a matter of the age. Maybe it's a matter of water losses. Maybe it's a matter of material. Maybe it's a matter of high pressures. No, whatever. The important thing here is to try to prioritize in order to invest in as best as possible. No. In this presentation, you will have the opportunity to discover two engines. No, the one engine when you have good quality data. No, when the uncertainty is low, you can use that engine that it is a matter of a multi-criteria matrix, and you can weight different values and you can decide. And the other engine, it's engine defined in a Shamir Howard paper in the end of 1969, where the quality of the data it's poor. In fact, that engine, it is only based on leaks. No, as much leaks have the pipe, more probably, more interesting to replace it, because maybe the cost to fix the leaks will be higher than the cost of the replacement. This is the simple theory that Shamir and Howard discovered in 1969, and this is the second engine that we will present. You will have the opportunity to see both. In fact, the multi-criteria analysis, what finally it determines, it's a age, it's a year that the pipe should be replaced. This is the most important thing. This pipe should be replaced in this year. This pipe should be replaced in this year. No matter if you are using uh, the low quality data engine with high uncertainties of the high quality data engine. Here you can see the big difference about the high and the low. No, on the beginning we have the our engine. The our engine, it's based on the our methodology. This is a public methodology, worldwide used to do that kind of approaches. No, but the problem here is that you should have high enriched data sets. If not, is maybe it's not good idea. Maybe you can, in order to deal with uncertainties, in spite you have high enriched data sets, maybe some data in that data set has poor quality data, and the way to manage the uncertainties is to weight that key as you want. No, this is the big idea of this method, that you can weight the different criterias as you want. If you are looking to prioritize, let's say, probability of failure, and you have a good quality data about probability of failure, maybe you can increase that weight. If you are looking for non-revenue water and you have good quality data of non-revenue water, you can prioritize. No, this is the idea, is that you can you can put different weights for the different criteria. No, in fact, it's a multi-criteria and risk-based, everything integrated. The failure model is a probabilistic, and the financial planning, it's integrated with budget allocation. It has advanced analytics, and could be used for large utilities with rich data. On the other hand, we have the Shamir-Howard engine, based on the Shamir-Howard method, that it's a cost-based optimization. It's what I said, no? At what moment it is better to replace the pipe, in spite of to fixing the different leaks that the pipe has, no? It has an exponential failure curve. It's focused on the reparation versus the replacement cost. It's a very simplified model, and it could be used for that utilities with limited data. No, in fact, the most important thing is to have the leaks, no matter material diameters. Maybe it's interesting to have at least some drawing, and to try to intersect the leaks in the drawing, including maybe the geolocation of the leak is not good, maybe the geolocation of the pipe is not good, and that method has issues to solve these uncertainties about geoposition of the data. No, this is the two methods that we will show you later on. Okay, if you have good quality data of everything, maybe you are able to work with the aware method, and putting these parameters. In fact, the aware method right now has these parameters. We are in a research development project, then we will increase these parameters with some more. But right now, the method is available to work with actual leakage. No, the based on the leakage that it has the pipe per year and per kilometer. Failure probability based on the material configuration, and in the different AI analysis that could provide quality information about the failure probability. Longevity, no, the remaining useful life of the pipes. To have this, we need to know when the pipe was built. Okay, longevity is the remaining useful life. Average circulating flows for conduits, for pipes. This is important because as much flow, as much circulating flow, no, more important, no, it's that pipe, and maybe the risk of failure, the damage of the failure will be big. In fact, this is the parameter that introduce the failure of the in the risk in a risk-based theory. This is the parameter that introduce the damage of the failure. The rest of the parameters they introduce the probability of the failure. Non-revenue water. In each DMA, for a given period, no, all that pipes that belongs to that DMA will have the same indicator, but you can prioritize this. No, you can look for pipes that belongs to one of DMAs with high non-revenue water. It is a matter that with the weight weighting matrix you can decide. And after that, there are two parameters more, which they are simply no, more indicators because sometimes to replace a pipe, it is not only a matter of technical decision. Maybe you need to introduce some strategic evaluation. Let's say, no, in the future, there will be a no urban development in this area. And right now we are trying to no, replace our pipes, putting best diameters in order to no, supply future water. Okay, good. You can decide to put some weight to replace some pipe only for strategic issues. Maybe in some municipalities happens, no, the street where the major lives, it's it has higher probability to replace the pipes, no, in order to be happy the measure, no, that the streets that maybe they are a neighborhood with low incoming people. I don't know, no. This is the strategic evaluation, no. Any water utility should have this possibility. And the last, it's compliance, no? Maybe we have materials, deprecated materials like iron, no, like fiber cement, which they should be replaced, and we can increase in our weight matrix, no, these values in order to make compliance, no. This is the multi-criteria calculation. And one of the idea is this tool has two steps, no? The leak assignation and the asset prioritization. No, the leak assignation it is the workflow to assign leaks to the pipes, and in order to deal with uncertainties, no, when we assign leak on the pipe, we have a buffer in order to assign that leak maybe to different pipes, putting some weight factor, no, inverted to the distance of the pipe. And on the other hand, the algorithm maybe should clusterize different leaks, different pipes in order to aggregate and to make good quality data. And for asset prioritization, in fact, our method has two rounds. In the first round, no, prioritizes the multi-criteria matrix, filtering with the whole parameters. After that, you can filter for a defined widget, and the top of this list will be applied in a second round in order to refine that prioritization. No? These methods ensures a strategic allocation of resources and maximizes the network efficiency. And the infrastructure value index, it's a index which determines, no, for any asset what part of the cost it has been deprecated, amortized, and what not. And for that reason, the idea is to have for the whole network a good infrastructure value index, which we consider that 0.5 is good, because it means that we are in the medium term. We are in the medium term. 0.5 should be a good goal to work with this tool. And this is here a little bit how we can manage the uncertainty and the importance of the GIS. The importance to have good quality data. And in this case, GIS Water, which is an open source tool, no, it's perfect to increase and enhance your quality data because it has lots of tools to work in this direction, no? And that's all. I think it's time to
Yes,
see
Xavier.
the live demo.
Thank you, Xavier, for your speech. And now
Welcome.
we will move with Namrata. She will be doing the practical demonstration, let's say.
Yes. Can everybody see my screen? Or
Yes,
I
I
think
think we can.
so. Okay, just a confirmation. Yeah, thank you, Nusrik. Yes. So I think this screen, if you have GIS Water, then you might be familiar with. But let me start by saying that having an asset managed tool to work with asset managed tool in general, you do not need necessarily need GIS Water. Of course, there are pros of having GIS Water schema because you have the whole schema of water supply, and through that you can link your asset managed schema. Um, but yeah, you can just start with the tool. So if you see here, I have the GIS water, I have the project type, which is the water supply that we are going to do. And then the schema is already created. It's an add-on tool, so it's from the advanced. So we just need to create a uh, database for asset schema, which practically is like a copy of all those asset inventory that you have in your networks. And then once you have it, you can just open your QGIS file as usual. Let's see how fast it works. Whenever I share my screen, it's a little bit slow, so hopefully you will not be bored. But I will try to make it as interesting as possible, though. the the demo. So once you have, so this is how the GIS water plugin generally looks like. We have sample projects. You have all the network elements such as valves, arcs, conduits, then sample points, all these things that you could possibly have in your network, you have that. And then once you have your database for the asset schema made, you can have these advanced tool for asset manage, because this is usually hidden because a lot of people don't necessarily use it. But if you want to use it, you just need to type true, and then you get a couple of buttons added on, which helps you to work with asset management. So we don't have a lot. It's just like 4 buttons, 4, and then you have like drop down. So altogether 5, but I would choose as 4. And to bring out the layers that you work with the asset manage, you just need to add on GIS layers from this AM, which is asset manage, and then you just add load all. And it's simple, one click, and then you have all the necessary layers in the GIS interface that you need for your calculations, asset prioritizations, leak designations, and stuff. So the existing assets are, as I said, it's the replica of the asset inventories that you have in your network. And then once you have that, the other thing that you need is leaks. As Chubby mentioned before in the presentations, there are like clusters formed to assign leaks if for say the leak is not typically assigned to certain arc. Sometimes usually what happens is somebody goes to the field and then say, oh, there has been some leak over here, but they do not know entirely which pipe is leaking. So this helps. These red dots are just the geolocations of what people see as leaks. And here in this, you can also relate to the IDs of the arc. So in GIS Water, each arc has a unique ID. And if the link is connected to the ID itself of the conduit, then it just automatically assigns to that pipe. If not, then we have this cluster process which assigns to the leaks. So how can we do this? Once, if you do the breakdown assignations, you just need to do a buffer distance. For example, we can just do 50 meters for now. And then here we use all the leaks that we have in the network. Just as a precautions, or just to say in the beginning, this is just a sample project. It does not relate to any real world data. So whatever you are seeing is like a demo. And once you assign the league, there are some algorithms that works and it's pretty fast. I hope we don't see the Murphy's Law when I say fast. It actually works. Now, when we have assigned any leaks, we get the summary, okay, period of the leaks, how many years of data do we have, how many indicated periods do we have within the indicated period, like 107, pipes without any intersecting its buffer. So those kind of informations that you can have directly on the screen. But if you want more detailed data, you can activate this layer called input assets, and you can see all these pipes. The red dash are the ones that are not assigned to any leaks, but the blue ones, the yellow ones, if you could see, light green ones, they are the ones that have been assigned to leak. So if you open this table, you have all these informations of the ARC ID. As I said, each ID ARC has a unique ID. You have the information of the materials, the diameter, the build date, this pressure at one point of the pipe and the other, the flow average, everything that you can have possibly for a network, you can add on this one. If you know about JS Water works with different expectations as well. So make sure to come to next week's webinar where you will have more information about GIS Water. But just to let you know that you can work on different areas as well for the asset manage. So once you have this, you see the leaks assigned, and then now we have to calculate the prioritize. We have to know which pipes we need to replace by what year. So we can say these as, okay, let's say 100,000 for maybe 10 years. This is the yearly budget. We can keep the same as description. We can use all expectations for now, but might I say you can also filter the pipes according to exploitations, according to the areas that you have, also the press zones, the diameters, the materials that you want to do the asset manage of. And I said 100,000, so I put the yearly budget. It's a lot of budget, but who cares? We are rich in the demos. So after that, since we say 10 years, I start from 2026, so which will be 2036. So once you have that, you can see all these catalogs, which are basically the information about the pipe materials, the pressure, the replacement cost, those things, the materials, and then the engine. As we said before, it works with multi-criteria, and all this sums up to 1. So you can decide which one to have better priority for your pipes. You can say, okay, my data is not so good, so maybe I should have probability of failure to the minimum or to the maximum. So it depends on you. And also sometimes you can prioritize the asset based on the years they were built, or the strategic, as Chubby mentioned, you can strategically put a pipe really, really important across a important area. So those things, and if we just run it, it gives some warnings, and then we proceed, and then it calculates automatically. So this is pretty fast. And then you can also have this possibility of exporting these results to an Excel file. So once you have this, if I save, so these are really important for the decision makers if you want to show numbers and results exactly. I can set demo 2. And then the Excel sheet is saved up. So before going to the Excel sheet, of course, we would see that. We can see here the summary. So what is the investment per year? I said 100,000, the year 2036, because it was for 10 years. And then the network current cost. I should also add that these are totally customizable. So you can put any cost as you have, because it depends on the countries, the areas. The IVI is the horizon year, as I said, IVI relates to infrastructure value index. So is it even worth it to replace, or is it worth it to just like move on and just focus on different priority in the asset? So these also give you with future one, how worth it is it to replace. And then if you close, in the asset results, here you see all these pipes that needs to be replaced. So not necessarily all pipes needs to be replaced in your network. So there are only certain pipes, and these certain pipes also can be distinguished by which year. Say in 2027, all these red pipes could be, if I do show feature count, so 18 pipes are to be replaced by 2027, and then 23 by 2028. So these way you can see clearly how, when, mostly when you can replace your pipes. So once you have this, maybe you want to see different results if you have certain different budgets. So with this asset manage tool, you can have as many results as you want, because we have this tool called results manager, and you can have as many as you want unless you are final with it. So we can see and compare how different it was from the previous one. So for example, if we do another process, let's do another one. Here, let's say we decrease the budget to 100,000 to 50,000, and then for 10 years again. And then we have the same thing as the same. I don't want to filter. You can also filter by selecting the features in the canvas itself, which is pretty much the same as QGIS select feature. And then you have the budget, 50,000 yearly, the horizon year 2036. I keep the whole same parameters the same. And then once I have it, I get the results again. And then I see now the results have changed. So with 50,000, maybe I'm prioritizing next year to replace more pipes, like that. And with the results manager, you can have both, and then you can decide which. You can also have the summary of the results that you did, basically, that you saw before, and then you can set this as corporate one as you finalize. Okay, this is the one that I want to, and then you can set the corporate one, and that's all. You also have these other layers called corporate assets. So if you just want to show your final result to the decision maker, this is what you can show. The result main and result compare are the last two layers that we have. It's just to see which one you want. Like if you have two results and you want to see them both at the same time, then you can choose one for one and the other for other, and then accept. The symbology would be quite updated at the same time, and then you see the results at the same time. So I would like you to take a key point from this demo is everything that I did is from GIS interface, everything. There are network pipes. You don't have to import anything extra. And also using the similar, just 4 buttons and similar tools of QGIS, you can achieve this on your own, everything open source. So I think that is one key thing. If you ask, is it possible to just work with large networks, or it's possible to also comply to smaller networks, then I would say no matter the dimension of the water network, it just matters what data you have. And since we have 2 engines, you can work with both data, and no matter what the dimension of your network is. I would say that's practically it for the demo. Oh yes, we have to see the Excel file. So once you have exported the Excel file, so you have all these informations of the calculations in the backend that you did through the multi-criteria analysis. So as we said, we have 2 steps. One, it tries to like find the longevity, which is the useful remaining years, and then calculate everything. And then it tries to do a double, the next step, multi-criteria analysis, and try to only prioritize those pipes that you need to replace. So as you can see, not all pipe needs to be replaced, and you are only prioritizing those pipes that is worth to replace and also within your budget. I think that is the most key factor here. So yeah, if you like to have this in your systems or learn more, just contact with us. And I think that's all for demo. I hope you like it.
Thank you,
Or it
Namu.
was more useful.
We have a few questions. Let me share the screen for a second. Okay. First question, is it necessary to have GIS water in order to use this tool? Okay. Maybe Xavi, you can answer that one.
It is possible to work with algae water because it works in an independent scheme and it's possible. In fact, it was born uh, as an independent tool from GisWater, but it's easier to work right now in this last version. It's easier to work with GisWater integrated. In fact, it's a plugin of JSWater, and in fact, it's desirable because it uses lots of data that came from JSWater, and it makes easy. As a resume, the question should be answered. Yes, it is necessary right now. In Spite, we like, no, we analyze to keep it independent, but the effort, it was big.
Okay, next question. Thanks, no
Okay,
comment. That's
sorry.
not a question, but
Sorry.
thank you to the one who submitted that message.
Sorry, David. I wanted to add something in the answer that Chavi said. Um, Can you hear me? Yes. I wanted to add something like with GIS Water, we have the webinar next week, but just to give a little bit of taste, with GIS Water, it's possible to do hydraulic modeling. And with hydraulic modeling, you get the pressure, flow, values, everything. And as I said, asset schema is basically the replica of the GIS Water schema. So the more the data you have with the multi-criteria analysis, as we said before, it also accounts the flow. You can have as many hydraulic modeling done, and then you can have the results, the pressures, the flows, and that could be integrated with asset scheme too, if you think that is the corporate one. So I think that is also one advantage of having GIS water combined with asset manage.
Key insight here, very important information. As Xavier said, this particular data flow, very important to predict not the probability of a failure, but the magnitude, maybe. So next question would be, does this apply to both water supply and urban drainage? Maybe, Namu, you want to answer this one?
I think for sure it just depends on what pipes you have and the assets you have. Mostly we have been working with municipalities that focus on water supply at the moment. But definitely if that is the necessity, we can definitely work it out with the urban drainage as well.
All right. How much data do we need in order to start working with asset manage? Maybe Xavier, this one, let's do one each.
As much and as better as possible. No? But in order to start, I said before, no, maybe the minimum data possible to work with GisWater, no, maybe some geospatial information of your assets with some data, no? You can start with an AutoCAD or with a single shape file only with diameter and material, no? You can upload this in GisWater, and after that you can activate the plugin of Asset Manage, and after that you can decide to use the Shamir-Hauer method or the aware. If you are looking for the Shamir-Hauer, it is mandatory to have also the leakage in a geospatial location. No? If you are looking to work with aware method, maybe if you don't have leakage, you can put 0 in the wave widening matrix for leakage. At minimum, the geospatial information of your assets and leakage could be desirable, because if you have low poor and low quality data, leakage should be mandatory in order that at least to have a good environment to take decisions.
And this is my personal follow-up to this question, but for the aware method, in terms of the age of construction of the pipe, date of installation, is it necessary to be precise?
It is not necessary. In fact, most of water utilities, they don't have the build date of the asset. Sometimes material, it was a matter of an epoch of construction, no? Let's say if they don't have data about build date of some asset, but some asset, it's of some material that it was common in the 18th or 19th, no? You can put default data for that material, no? In fact, it's what we do when we don't have build date for some assets. But if you don't have build date for any asset, maybe this is not a good criteria to use, no? You need data, because if not, no, the uncertainty is so high.
Thank you, Xavier. Goodbye, Amir, and thank you for joining today. So next question for Namu. How does this algorithm deal with uncertainty in our data?
Yes, relating to the slide before, maybe we can go to the slide.
Which slide in particular? This one, maybe?
Yes. So as we said, we have two engines, and both of them has different strategy to work with the uncertainties. So in the aware, it's the uncertainties are medium to good because you have good data. But with the Summit Hubbard engines are the ones where you don't have good data. It's meshy, incomplete, unreliable data sets, everything. What we try to do is we have these sets of complexities or like criterias to involve with, and how the data is treated is also really important. In the aware technology, aware strategy, I would say, we have these reliability scores where you weighted everything, but in the Howard, it's more like probabilistic ranges and distributions. In that sense, the uncertainties are quite unavoidable. But in the way, if you have great data, then it can be quantified and managed as well. So I would say with these two separate engines, there are different ways, but most importantly, it depends on what your data are at the first place.
Thank you. So I think we have two questions left. This one for Xavier. I was wondering if it could help for hotspot points analysis for sewer networks with rainfall data.
It's Let me say, in spite that this, first of all, in spite that this tool could be used for water supply and for sewage systems, um, I should say that we never use it for sewer systems. We always use it for water supply. In fact, the multi-criteria matrix is defined for sewer, water supply systems, no? Let's say non-revenue water, for instance, no? Or number of leakages. The thing is that I don't know if we can help you in this hotspots point analysis, no? Maybe this should be analyzed in a deeply way. If you have thinking in some specific project or some specific thing, maybe we can discuss later on after this webinar. Because right now I don't have clear what I should answer for you.
Thank you. Namu, will this actually reduce failures or just change the way that we plan?
I think both. It will improve the way you plan because you are prioritizing the assets that you need to replace. And once you are prioritizing the assets based on the necessity of your infrastructures and the money and your network capabilities, I think at the end it is just going to reduce failures. Not exactly saying like there will be no failures at all. Of course, there will be, but it will definitely help you plan more and then decide what is best for your network at the end.
Thank you. And we have time for both questions, I think. First one, Xavier, how long does it take to implement Asset Manage?
Good question. In fact, implement asset manage, no, could be, it will be desirable to be implemented with GSwater, no? And to implement GSwater in a corporate environment is to implement a corporate GIS in a water company. And this has a process. Because this tool is a clear tool for water utility. It is not a tool for an engineering company working with hydraulic models. No, you can use GSwater to work with hydraulic models by your own, but in this case, it is a corporate tool, no? It is a tool which has also the leakage and blah blah blah, and prioritize the investments on the next 5 years, etc. And for that reason, okay, the implementation of any corporate GIS, it takes time because it means to make an initial migration, to make the definition of the roles, first of all, no, the roles. After that, to clarify the data model. After that, the migrations, trainings, and connection with another corporate tools like CRM, SCADA, CMMS, etc. And it is not easy. It's a complex process. Our experience says that it's possible to do by your own in your company. In fact, there are companies, water utilities, that they are implementing GSwater by themselves. But in this case, here is our business model, no, is to help you to make this implementation as fast as possible and without no headache and with compliance, no. It is what our team loves to deploy, to help to deploy that kind of tools in different environments, no, all over the world, no matter the mature degree of the company, no matter the continent, no matter the place on the world you are living or working on. No, this is what we do. But okay, answering your question, our experience says that to implement GIS Water is a matter of from 3 months to 8 months. This is normal time to deploy one tool of these characteristics in a corporate environment.
Thank you. And now last question, Namu, is the prioritization of assets transparent or a black box?
Well, the whole asset managed tool is open source, and the whole idea about open source is it's transparent, so there are no black boxes. Um, so as you also saw that Asset Manage had like clear steps of multi-criteria, all those results that you saw in Excel sheet, that all the values that you had, you can see clearly how the values are being calculated, how you can see. So I think it's pretty clear if it's transparent or black box. So yeah, just to make it sure it's 100% transparent. If you want to add something more, you can just add it. It's about open source. So if you have any additional criteria to put on to this asset management, then you can definitely add in also. So it's all transparent, whatever you like it.
Thank you. And with this last question, we end the webinar of today. We would like to thank everyone for attending. And of course, the fact that you are here and the fact that you want to learn with us is the fuel that we need in order to continue working and continue developing and continue bringing these solutions to everyone who is interested. So many thanks, and we hope to see you next week in the next webinar about GIS Water.
Thank you so much.
Thank you so much.